Hello guys, welcome to my YouTube channel. In this video we are going to discuss about the implementation of motor using Arduino. What is a motor using Arduino? Design. Making use of the Arduino microcontroller to control various electronic components like motor, pumps, valves and many other mechanical devices. Functionality. The primary functions of these motor systems is to automate machines or function previously done manually, making them more efficient. Types of motors. Motor control. Different types of motor can be employed, including servo, stepper, brushed and brushless types. Overview of motor using Arduino. Hardware overview. This is an image of the hardware overview. The circuit board is the central device on which the motor control system is built. Power supply, motor driver and microcontrols are the integral part of the microcontrol system. Microcontrol basis. The main idea behind microcontrol using Arduino is to regulate the voltage and the current levels provided to the motor to control its speed and movement. Programming the microcontroller. The program for the microcontroller can be written with the use of Arduino IDE and uploaded to the Arduino board, which controls the motor accordingly to the code. Components and tool required for the project. Arduino board. The microcontroller board is the central nervous system for the motor control system. Motor driver shield. A motor driver shield is used with the Arduino board to enable the pin's integral phase with the motor control system. Motors and regulated accessories. Depending on the type of the motor chosen, accessories like gears, pulleys and shaft may also be needed. Breadboards and jumper wires. These are the important for making the electronic connections between circuits and testing various components before they are added to the microcontrol system. Coding for microcontrol using Arduino. Structure of the code. Starting by creating a skeleton code for the microcontrol program that includes a step-up and loop function. Defining and assessing pins. Pins usage and memory allocation should be defined, followed by assessing the input and output pins. Setting up the motor. The motor features to be used should be defined before the program begins and its settings should be set accordingly. Executing the program. After the code has been written and the system has been wired up, the program can be executed along the motor control operations to be taken place. Testing and troubleshooting the motor control system. Testing the motor. Power the system on the use of the code to move the motor slowly and steadily. Watch out the potential derivation in direction or speed for the intended goals so that they can be fixed. Diagnosing common issues. Common issues like overheating, insufficient power supply and incompatibility should be looked out for when testing the motor control system. In these issues arise, correct them by disabling and reassembling the motor control system in appropriate replacement components. Applications of motor control using Arduino. Exploration of Mars. Motor control system using Arduino are used to power rovers for space exploration, where remote control is necessary to direct the movements of the rover. Automated factories. Motor control systems can automate the assembly line process in factories, making the manufacture process more efficient and cost effective. Aerial mapping and photography. These systems are integral to UAVs and drones for surveying aerial maps and photography. Conclusion and further work. Conclusion. In conclusion, motor controls using Arduino is a critical aspect of motor control systems and automation. The ease of coding, low cost, and flexibility offered by an Arduino and related devices make it an ideal solution for motor control. Further work. Further work involves exploring different types of motors and creating more sophisticated motor control systems with Arduino for broader and more complex applications like autonomous cars and CNC machines. Thank you.